So I'm going to make a quick series about making beehive frames, and to start and just mention lumber selection. So if you're going to Lowe's or Home Depot, then you can just stop. So I get my lumber for beehive material from Eastford Lumber in Connecticut. There's lots of local places, they have the best lumber. Their number 2 1x10s are like other stores' clear pine, and their 2x4s and 2x6s are square, straight, no cupping. They're nice. I would have gotten 2x6s because that's the right piece of wood for this, but a 2x6 right now is about $20 and a 2x4 is $14. And it just makes economical sense to get 2x4s for now. So anyways, as far as making your frames, step 1 is lumber selection. Alright, so this is the way we're going to do this process. I made very detailed instructions for all parts of the frames. We are going to start with the top bars. As you can see on the top, all cuts critical, quality control, quality control, quality control. If you're going to make these, if you haven't made them, start with your top bars. If you can't make a top bar, then you can't make a frame. Side bars are easy, bottom bars are easy. Top bars, if you do your process right, they're easy, but you have to be careful with them. Just to reiterate that, as you can see right here, all cuts are critical. 15 cuts per piece. Plenty of opportunity to screw this up. So, following these instructions, we have our wood selection. We're going to start on step 1. Chop saw, set up, install a stop block with sawdust relief at 19 inches. Make a test cut, adjust the stop block as needed, and then we're going to cut everything down to 19 inches. We have our stop block. Alright, this is a process, and my goal is to make this efficient enough to where it's worthwhile making them rather than buying them. Making beehive frames is pretty damn tough to make it worthwhile to make rather than buy. Right? So I've been working on this process for a while. Honestly, long enough where it'll never be more efficient making them than buying them because of the 2 years I've been working on this process. But anyways, hopefully this helps. So organization is one thing. The less times you touch a piece, the more efficient you are. So we have a nice rolling table that we can stack all of our cut pieces on neatly, and we have a system where I unload them and they're relatively close. I actually did put them over there earlier, but that was just for the camera. They get stacked over right where I need them off the truck to begin with. Alright, so here we are on step 2. Step 2 is done on the table saw. We install a 5/8 dado at a 9 degree, 5/16 height to the high side of the dado blade. You set the fence to the left side of the blade so that it is 19 inches from the outside of the top of the dado blade. Yeah, outside of dado needs to run flush with the piece. Right, so all that's saying is to set your fence so that the top, the outside of the dado blade is 19 inches. Right? What that's going to do for you get it so when you run your piece through, your dado blade is going to cut flush to the outside of your piece. This is what's going to set on your frame rest right here. Right? Use your miter gauge and run the piece 90 degrees, flat on the table, tight to the fence. Compare to your pattern and adjust as needed. Rip all pieces both ends. So we've already compared. We're all set. Everything is good. So now we're going to start running them through. And quick note, it's setups like this, right? This has to be set up absolutely perfectly. So the more you make, the more efficient you get. If you're going to make, God, 10 or 100 of these, you know, it's not very efficient. We're not making that many. I think I'm making about 400 right here. So the efficiency isn't quite there yet. Now me personally, I plan on making them in batches of about 2,000. And that's when you'll start seeing those efficiency gains, because your retooling and your setting up of your tooling is the biggest time consumer. Alright, so we had a little bit of an interruption there. I had to get the videos off the camera because it was getting full, but we're back. So we are on to step 3. Step 3 is still on the table saw. We keep our 5/8 dado. We're not going to use the whole thing, but it saves time from changing out the dado blade. We're going to set it to 0 degrees, 3/16 height. Should have mentioned the way I check my height of my dado is I set my ruler to the appropriate height from the bottom, and I set that on there, and I run it over to the peak of my blade, which is set at the center. So after that, we set our fence 18 inches measured from the outside of the workpiece to the inside of the dado. So here's the outside of our workplace, here's the inside of our dado. That's where we get our cut. Using a miter gauge at 90 degrees, run the piece flat on the table and tight to the fence. Compare to pattern and adjust as needed. Now what you are going to be checking for on this cut, because this is, all these cuts are critical for the top bars, but this is one of the more critical ones. So what you will be checking for is to make sure that your height that is left over is the same as the depth that you're going to be cutting on your sidebars. And additionally, since your sidebars will be 3/8, you want to make sure that it is 3/8 from the edge of your contour, of your angle, to there. So that way your sidebar sits in there nice and flat, gets good surface contact. You don't want to have this so you don't get surface contact. It's very good. Last video cut out a little early, but I did mention in it, it wasn't caught. If you get a piece that has a cup to it, put your cup down, hold your front down tight till you get halfway on your blade, and then roll it back and cut the back so that you get as straight a cut as possible. Alright, Alright, now here's the deal for ripping these down to top bar width. Now, I used to use the table saw and just rip them one at a time, but like I said, I'm trying to really crunch my brain and get this efficient as possible. So our next step is going to be on the shaper, and we're going to be stacking trim saw blades. So for my shaper, which is a shop box, start off, I have a 3/4 inch spindle. Start off with a 1/2 inch spacer, or sorry, a 3/4 inch spacer. Followed by a trim saw blade. I'm gonna raise that up just a little bit more here so it doesn't, no metal on metal. There we go. Right. Now the thing is, when we're doing these spacers, these are 1 inch, right? But obviously the kerf of your blade extends past the body of your blade. So if you put a 1 inch on there, you're going to end up being shy. So I made these, which are exactly half of the thickness that the kerf is bigger than the body. So then I put one of these on, then a 1 inch spacer, then one of these, other blade, blade. We have just enough to get a nut. Now once we cinch that down, we get all the threads. We do not have 2 nuts. If you do this and you kill yourself, that's on you. We have 1 nut. We will cinch it down tight because this will kill you. Alright, so we're all set up. Our blade heights are good. We did some test cuts. Now you don't have to worry about the 1 inch here because there's no messing that up. You just got to make sure that this is 1 inch, and then you're good to go. This is my push stick that I will improve upon at a later date. As long as I get the blade out before I get to my handle, I will not hit any screws. Let's see. I feel like I should say something about safety. Safety is important. Okay, here we are moving right along. So I didn't address this before. I'll just read the rest of the instructions, right? So you set it up, you raise your spindle, you set your fence right, use a push jig, verify the bottom is the same, use the push jig to make cuts. I want to stress this. Watch the angle that you're holding your push jig as well as the angle that you are pushing your pieces through. You don't want to have a piece off of the table in any way or your push jig. Each piece requires 3 passes, leaving 5/16 inch waste, which we will end up just cutting all those in half, and those will be this winter's kindling. So here we are on our second page, and we're going to switch steps 5 and 6. It doesn't really matter, but I had a 5/8 inch dado in. Step 5 requires a 1/8 inch dado. Step 6 is a 3/8 inch. So when I made this whole process, apparently that's the way I did it, but now that I'm doing it off of the sheet, it makes sense to just go 5/8, 3/8, 1/8 rather than 5/8, 1/8, 3/8, right? No reason to take something back off just to put it back on, right? Efficiency. So we're going to do step 6 on the table saw, which is install 3/8 inch dado blade at 1/8 inch height. Set the fence on the right side of the blade at 5/8 from the inside of the dado blade to the fence. Right? So 5/8 from the inside of the dado to the fence. And we're going to use a miter gauge at 0 degrees with the 3/4 inch side flat to the table. Right, so there's our 1 inch side, there's our 3/4 inch side, which will be flat to the table. And flip over and make a billion, million, zillion cuts. I should point out that I'm comfortable doing 5 at a time, so that's what I will be doing. If I had, a little bit bigger hand, if I was like 6'6" or something, then I could do 6, but I'll be doing 5. The instructions clarified, and this is important, that being tight to the fence is more important than being flat to the table. If you're not flat to the table, it's not going to be very much, right? And all that'll do is that'll change the direction of your sidebar, which isn't good, but realistically, it takes a lot to be not flat. Alternatively, if you are not tight to the fence, if you are too far this way, then your sidebar will have a space between this part of your top bar and the sidebar. And if you're too far this way, then you won't even be able to get your sidebar in, because your 3/8 will run down here and it'll overlap on that, which you can fix with the bandsaw. Clearly I've done it, but it's not efficient to fix things like that, so don't do it. Okay, here we are. This is actually day 2. I'm only about 2.5 hours into this, but this video recording and bringing the memory card to the computer and uploading and stuff is taking a bit of time. But I think it'll be worth it. So we're making a few changes to the process. As we said earlier, step 6 becomes step 5. Additionally, rather than do step 5 after 6, we're going to do 7 after 6, or 7 after, yeah. Either way, right, so we're changing 5 to 7, 6 to 5, and 7 to 6. And it's just for efficiency as far as retooling time. So we already did step 5. We cut all of our slots for our sidebars to fit in. So now we're going to move to the new step 6. My old step 6 involved the shaper, and what that was I have this 2.5 inch straight cutter that I would mount on there, and I made a jig, and you could stack all the bars on there and get all those 45s on a whole bunch all at once, right? But the stacking time took away every last bit of efficiency that made. So I'm just going to do it on the table saw again, because it really is just faster for me. I can do 5 at a whack, and that's the way we're going to do it. So our setup for the table saw. I left the height the same height as before. Put it on a 45-degree angle. Left the 3/8 dado on there because there's no reason to change that out at this moment. And then the fence is turned to the right side of the blade at 19 3/16 from the inside of the blade to the fence. Alright, so real quick, apparently no YouTube video is complete without a plug. So inside the Hive TV, Umberto Boncristiani, like and subscribe to his channel. He does some good content. Alright, so here we are, we're on our next step. We made it so far without disaster striking until just a second ago when my pile collapsed. But luckily, this is the point where I'm grabbing them one at a time, so it's not that bad. So we are making our groove. Gentleman on YouTube, I had a little funnel made, and a guy on YouTube was like, "Oh, I'll just use a double featherboard," which is a pretty good idea. So I have one featherboard in there. I'm not even sure if I'm gonna go with the double featherboard. I might just make a jig that just sits right over this, but then holding it down. Yeah, I think actually that's what I'll do. I'll make a jig that comes over it and some pins, so I can just pin it with dowels or something. Easy on, easy off. And that'll be it. So anyway, alright, so final step. Well, this is final step with no wedge, right? There's no efficient way that I've thought of that you can make a wedge in these things in a home shop. So final step, step 7, table saw. 1/8 inch dado blade at 5/16 height. Adjust the fence so that whatever jig you're using makes it so the dado blade will be centered on the top bar, not the bottom bar. Make a test cut just as needed. Make cuts using your push piece to push the preceding piece through. Alright, so I'm out of room in my box, so I gotta go track down another box. So we're gonna finish this video. I still have a little pile left to do. Trying to think. All in all, this was pretty successful. This was my biggest run with this process. I've done, I started off tinkering, 10 here, just adjusting it. Then I did a batch of 50 and I adjusted it again, and this is my first time going since I adjusted it last time. The attempt should have produced 480 top bars. I got 468 so far, so I had 12 junk ones. Some of them were material, most of them were my error, and the error specifically was on ripping them down to 1 inch. I did specify it in my instructions because I knew it was a problem last time. It's just me holding them down flat to the table when I'm running them through. I mean, really, I think I only did it on one piece, because the problem is, you know, when you're cutting multiples, if you mess up one, you're messing up at least three. But if you mess up that one in the beginning of your cut, right, that's 7 pieces that you're going to mess up. So if you're going to do that, don't mess up, because it multiplies very quickly. But the good news is that means that